Okay, so in 5.2, we start talking about proving trigonometric identities. And so here are some general guidelines they give us for verifying trig identities. So the first thing you got to do is you're going to pick which side you want to work, okay? Each equation's got two sides, obviously, and it's usually easier to start with the more complicated looking side. So you're going to simplify your chosen side until it is identical to the other side. And we don't work across the equal sign. So we don't work one side and then go to the other. Okay, so you work one side or the other until you get what's on the other one. Alright, so another thing to do is, like I told you before, this is one of my favorite. If I'm stuck and not sure what to do, I can change everything to sine and cosine. I can always change back later if I need to, but sine and cosine are usually easier for us to deal with. Step 3, we're going to look for algebraic operations, such as, if there's fractions, can I add or subtract them? Can I factor something out? Can I distribute? Can I square terms? Can I multiply by conjugates? Can I multiply terms? Or can I multiply by a clever form of 1? Meaning, can I multiply the top and bottom both by something that will help me? Remember, that has to be the same thing. That's why they said it's a clever form of 1. Then look for the trigonometric things you can do. If there are squares of functions, think about your Pythagorean identities. Remember that cosine and secant are reciprocals, sine and cosecant are reciprocals, and tangent and cotangent are reciprocals, and reciprocals, when multiplied, always equal 1. Keep looking at your answer. That is your goal. Make sure you're on the right path, okay? So keep looking. What do you need? Do you need all signs? Then don't put a cosine in the formula if you just need signs, okay? Remember that there will often be more than one way to verify an identity. Don't quit. If one idea doesn't work, try something else. You'll see there'll be times when we're working on stuff together, guys, that I'm going to get stuck. You're going to get stuck and not be able to guide me, and I'm going to tell you, I'm not sure where to go from this way. Let's try another route. Same thing. If you are working it at home and you get stuck, try another route. Go back and say, okay, this way didn't work for me. What can I change? And then step 7 here, I'm not going to require it, but you can. A lot of times when you see identities proven, you'll see the letters QED at the end. And it just means that it is demonstrated. It's like saying it is finished. Okay? We have proven it. Alright, so let's move on. Let's actually try to prove this algebraic identity. Like I said before, these are nice. It's the same thing as what we did before, but now we know when to stop. Before, let me turn my pen on here. Before, I would have told you in 5.1 to simplify that. You wouldn't have known what it was equal to. You just had to simplify until you couldn't simplify any further. Now I'm going to tell you you're done when you get a 2. Alright, so here's what I do. When I am proving something, I'm going to draw a line coming out of my equal sign. And because I can only work one side or the other, okay? But I know whichever side I'm not working is a side I need to be able to get the other one equal to. So, do we want to work the left or the right? It's almost always easier to take something harder looking and simplify it to make it smaller than take something smaller to make it bigger. So let's try to do the left side. So I'm seeing that we're subtracting fractions, but first thing I notice too is I have a difference of squares in both of their numerators. And so I'm going to factor that out. So remember, difference of squares. You take the square root, so the square root of x squared would be x. And you put it at the beginning. And you take the square root of the second, which is 1, put it at the end, and one of them's going to have a plus, one's going to have a minus, over that common denominator. Minus. I'm going to do the same thing here. Should have left myself a little bit more room. That's okay though. 2 parentheses. It's also a difference of squares. So the square root of x squared is x. Square root of the 1 is 1. And because it's a difference of squares, one's going to have a plus, one's going to have a minus. And how did I know to do that? That's what I saw first. Some of y'all may have said, oh, well, we're subtracting with fractions. Let's combine them by finding a least common denominator. You can do that. You'll get the same answer at the end, guys. Okay? So now look at this first fraction. Well, I notice I have an x minus 1 on top and bottom. So I'm going to take that out because we don't really like fractions. So it makes it a little easier. So I've got x plus 1 minus. In the second parenthesis, they both have an x plus 1. So I'm going to take out an x minus 1. Now remember, because they were together in that fraction, that's why I put parentheses around them. This first parenthesis I don't really have to have because there's nothing other than a 1 in front of it. If I distribute it, it doesn't change it. But the second parenthesis has a negative 1. And so I distribute it. And then we're going to combine like terms. What's x minus x? Cancel. And we have 1 plus 1, which is 2. And looky there. That's what we were trying to prove, that it was equal to 2. So it is proven. So we could put QED. We have demonstrated it.